Our final step of homework is the second research question. In this, we have two hypotheses to test. One we'll do in class, one you'll do for homework. In class, we will test the null hypothesis that we have an even distribution of males and females in each group, in the healthy and injured group. Because sex is nominal data, we can't use normal parametric analysis. We have to use a chi-square. Dr. Fleischer has talked about nominal and ordinal data and how to manipulate that. So let me show you how to do that with SPSS. All right. And just to keep it clear in your mind, we're sort of building a 2x2 table. So we're looking for the distribution of males in the healthy and the injured, and females in the healthy and injured. So the hypothesis is there an equal distribution of sexes in the two groups. So that's the null hypothesis. If the value of the chi-square is below 0.05, then we would reject the null. If it's above 0.05, we would accept the null. All right, so let's run that analysis. Make sure our data is not split. Make sure that is off. It is. Organizing all data, all cases. Perfect. And now we're going to run our chi-square. So to find a chi-square, it's a descriptive type of statistic called a crosstab. So you go under descriptives, and we're actually going to create a crosstab, which is a 2x2 table. So if you go back and look at what I did in Excel, if you pause the video, I made the rows males and females and the columns healthy and injured or group. So in my analysis of variance, what I'm calling sex is sex. So this is the F and the M's, or females and males if I use their full label. Okay? So I want group to be in my columns. I'm sorry, sex. Sorry. Start over. So I have group in the columns, just like I said, and I have sex in the rows. Make sure I'm correct. Sorry for the confusion. Yeah, sex is in the rows, groups is in the columns. Analyze, descriptive, crosstabs, sex rows, columns, perfect. Yay. Okay, so if we go over here and we look at statistic, we have to turn on the chi-square analysis. Continue. Now just for an educational purpose, I'm going to have the cells show what is expected. It defaults to what is observed, but if you have 20 people and you have 4 cells, you would expect basically a breakdown of 5 people in each of the 4 cells. Now this is a small n, so we're going to get some warnings or some errors related to this, but this is all to teach you how to manipulate this data. So with 23 people, it's going to be a fraction of a person, but basically you're going to have 6 people in each cell. That would be the expected value with that. So I just want to show that to you so you can understand what the analysis is actually doing. There's other cells or other options, but those are the 2 critical ones that you want to do for this analysis. Then you hit OK, and you can see all 23 subjects that I have, the 14 in the healthy and the 9 in the injured, were used for this analysis. And then here's the breakdown of the 2x2 table. So if I copy this over into my Excel document, it's a little easier to sort of see what's going on. So this is my count, and this is what the computer expected based on the number of healthy and group. It didn't work out exactly evenly, but that basically works out based on the smaller number of injured. So what it expected to see was 7 and 4.7, and what we actually had was 7 and 5. So we have 7 and 5. So pretty close to what the computer expected based on the percentage of people we have in each group. We had 7 and 4. 7, and 4. So this gives us our 14 and our 9 subjects. So you can sort of see, because these are really close to what the expected count was, guess what's probably going to happen? We're not going to see a significant difference with our crosstab or with our chi-square. So let's go back and confirm that. That's why I always try to look at the data first before I just try to interpret the p-value. So I go down here to my chi-square. Here's my chi-square, copy. I can pull that puppy over here so I can see it, interpret what's going on there, paste that puppy in, and the cell value, let me go back to this real quick so it's a little easier to see. The p-value is the asymptotic significance. We almost always look at two-sided, and you can see the p-value is 0.79. So it's way over 0.05. This is the value of the chi-square. This is the 0.79. Now it'll give you some warnings down here. It says 2 cells, or 50%, have expected counts of less than 5. The minimum expected count was 4.3. So when you have a small n like this, the chi-square can be interpreted a little bit incorrectly because you have such small values, and then you default to your Fisher's exact test. But if you look at Fisher's exact, which is automatically given, you basically get the same result, that there's no significant difference from the observed and expected. So, in the homework I asked you to write out a quick interpretation, and so if I go back to my Excel spreadsheet, based on this I can put my p-value here. P equals 0.795. So that's for my chi-square. And so my interpretation would be the hypothesis was supported that there was an equal distribution of males and females in both groups. And then your chi